So now we can finally move over to polygons, which is the second part of geometry at grade 10. So lines, angles, and triangles are topics that we discussed at grade 9, but we have to revisit those topics at grade 10 because we talk about it at grade 12. So at grade 11, we very rarely use similarity and congruency, but it's used extensively at grade 12. And so having a good foundation this year and having all of your notes in order this year will ensure that at grade 12, you have no problems. Right, so let's move on to polygons and explain exactly what polygons are and how they relate more specifically to parallelograms. Now, this is the second mind map that you need to keep at the back of your mind. The first mind map is what I've just showed you. The second mind map will be this. And you have to know how every shape develops from the polygon. It's extremely important. I cannot emphasize this enough. I've already talked about properties and theorems when I discussed the isosceles and equilateral triangle theorems, right? But I'll talk about it in more detail in this part of the course. So what we have and what we start off with is a polygon. So the word poly means many and the word gon means sides. So it's basically a figure that has many sides. When we come down to a quadrilateral, it's basically a figure that has 4 sides. From a quadrilateral, under specific conditions, we can turn a quadrilateral into a trapezium. Now that's very important what I just said. So from a quadrilateral, under specific conditions, you can make a quadrilateral a trapezium. And from a quadrilateral, under specific conditions, we can make it a kite. From the quadrilateral, under specific conditions, we can get a parallelogram. From a parallelogram, under specific conditions, we can get a rhombus. From a parallelogram, under specific conditions, we can get a rectangle. But we can go a step further. We can bypass the parallelogram and we can say from a quadrilateral under specific conditions, we can get a rhombus. And this is what's extremely important about this mind map, is it shows you how every other shape develops from some other shape. So how does a rhombus develop from a parallelogram? Or how does a rhombus develop from a quadrilateral? Is what we are going to discuss in this video, right? How does a rectangle develop from a quadrilateral? How does a square develop from a quadrilateral? Or a square develop from a rectangle? Now, the more common one, most of the students know, is that a square is basically a rectangle with all sides equal, right? So can you see how one shape develops from another, right? So this is why we have to discuss these two ideas, properties and theorems. So let's read what we have at the bottom. In the diagram above, I explain how each shape develops from the polygon to the quadrilateral and so on. Once we define the properties of the shapes, remember the properties are the characteristics of the shape. We can then use either a single property or a group of property to prove any other shape from any other shape. I will explain what this means, do not get confused. Right, so let's look at an example to make sense of what we've just said. If you're given a quadrilateral and you're required to prove that the quadrilateral is a parallelogram. So let's say that this here was given in your exam paper. Right, they don't tell you that it's a parallelogram. They call it a quadrilateral. Right, so remember this is a quadrilateral. It's a 4-sided figure. So they can call it a quadrilateral or they can call it a parallelogram. Because remember I said it comes from here. This parallelogram comes from here. So I can either call it a quadrilateral or a parallelogram. But if they call this a quadrilateral and they say prove that this quadrilateral is a parallelogram, then you can either use a single property or a group of properties of the parallelogram to prove that this quadrilateral is a parallelogram. So think about what I just said. There's certain characteristics that make up a parallelogram. So think about it like this. Maybe you have a specific eye color, right? That's distinct to you. You maybe have a specific voice tone. You may have a specific skin tone that is distinct to you. That's what makes you special from someone else. And so that's exactly what we think about when we're talking about these shapes. These are things that there's things that only this shape will have. There's things that makes this shape special from some other shape that we can use to prove that this quadrilateral is a parallelogram. Understood? So when we get there, you'll understand the difference between a property and a theorem by using this exact idea. Right, so let's move on. Right, so let's define all of this terminology and so we can move forward. A polygon is a flat 2D enclosed shape with at least 3 sides and angles. So it must have at least 3 sides and angles. A quadrilateral is a type of polygon which has 4 sides, 4 vertices, and 4 angles. The sum of the 4 interior angles has to be 360 degrees. We then have 6 types of quadrilaterals. Now, if you have this mind map down, you can see from the quadrilaterals we have 1, 2, 3, 4, 5, 6. So from this, 6 different quadrilaterals stem from it. Right, so let's understand what these 6 are. Right, I will list them strategically so that we can make meaningful connections between these shapes. And I will list all of the properties of the shapes, and you should study these properties because it'll be useful when we discuss other topics. Now, let's understand these properties. And you have to understand this is extremely important. I do not want to jump to theorems if you do not understand these properties. If, again, I'm using if and then statements. It's a type of logical statement that we will use in maths. If given these quadrilaterals, then we can use these properties. So if in the paper, I told you, the diagram below is a trapezium, what can we conclude? We can conclude that one pair of opposite sides is parallel. So even though your examiner may not put these parallel signs on it, understood? They may not draw these signs on the diagram. But automatically, if they tell you that the figure in the paper is a trapezium, then we can make use of what? The property. The property is what? That one pair of opposite sides is parallel. Because if I talk about you, there's something in someone's mind that makes you different from someone else. And so they will always think about that one thing. Like maybe, like I just said, your skin tone, your voice tone, or something, or your eye color, whatever it may be. That's that one thing that makes you different from some other person. And so it's the exact same thing with shapes. So if they talk about you, then what can they conclude about your eye color or your skin tone? It's some other thing. So in this case, when we're talking about shapes, we're saying if, let's do what I'm saying, if you're given a trapezium, then automatically you go on your diagram and you put these parallel signs. Right, why is this significant? Because if I told you that this figure A, B, C, D is a parallelogram, and if I put a transversal, what did we just form now? We've just formed fun angles. So that's how we can start linking the topics from lines, angles, triangles, and now we're coming to polygons. Right, but let's not move too ahead of ourselves. The point that I'm trying to make is that if you're given the trapezium, you can use the property, right? And then the area of a trapezium is half the sum of the parallel sides multiplied by the perpendicular height. So what's the perpendicular height? It's this height here. It must be perpendicular, has to be perpendicular, right? So it'll be half the sum, so it'll be this side plus this side. So what the lengths of these sides are, multiply that by half and multiply it by the perpendicular height. Right, so let's move on to the next polygon, which is the kite. A kite is a type of quadrilateral with 2 pairs of adjacent sides equal with diagonals that intersect at right angles. So basically, this is a kite. This side and this side is adjacent. This side and this side is adjacent. So this is one pair and this is the second pair. So they must have 2 pairs of adjacent sides equal with diagonals that intersect at right angles. Right? So let's discuss the properties. 2 pairs of adjacent sides are equal. So if in your paper, the examiner tells you there's a figure that represents a kite, what can you conclude about the adjacent sides? They are equal. So this will be one pair that's equal, and this here will be another pair that is equal. So it has to be 2 pairs that are equal. What's the next property? We can say that the longer diagonal bisects the shorter diagonal. Now, what makes up the longer diagonal? The longer diagonal is generally the diagonal between the equal sides. So see here, these are the equal sides here, and these are equal sides. So between these equal sides will be this line here. That's what we call the longer diagonal. So if in the paper your examiner tells you that this is a kite, they draw diagonals on it, what can you conclude about the longer diagonal and the shorter diagonal? The longer diagonal cuts the shorter diagonal in half. Say bisects. Remember we said bisect, intersect, and dissect. Understand the distinction between those 3. Right, so once you have that, that's one property that you can make use of. That's another that you could make use of. Again, right, when will you make use of these properties? Will always be situational. So it'll be dependent on a specific question. It'll be dependent on what you are required. Maybe you need to use this property. Sometimes you may not require you to use this property. So it depends on the specific question that you're given. But what's important is that you must remember all of the properties, right? Because you never know where these situations can be useful. The diagonals intersect at 90 degrees. If you're given a diagram and the examiner tells you that that diagram is a kite, what can you conclude about the diagonals? You can conclude that they intersect at 90 degrees. It's symmetrical about the longer diagonal, which implies congruent triangles. So what are we saying? Listen to this. Extremely, extremely important stuff. What are we saying? See this triangle here and see this triangle here. What can we conclude about these triangles? They are the same. Why? One side, another side, and what side? This side here is common. And so by congruency, we can say that triangle 1 is congruent to triangle 2. And just by the simple property, we can create various questions from it. And that's why when you're given a question, you can see why this is very important to keep at the back of your mind. Because we're relating it to what? Remember, lines, angles, triangles, and polygons. We related a polygon to triangles. And what's specifically under triangles? Congruency. And so when you're given a question, and if you're given a kite, think about congruency, because you most probably are going to use it, right? Angles opposite the longer diagonal are equal. So here's the longer diagonal. Where's the angles opposite it? There's it here. So these angles here are equal. The longer diagonal bisects the opposite angle. So there's the angles here. Can you see these angles here? It bisects it. So if I zoom in here, this angle here and this angle here, what it did? It cuts it in half. So this angle here is equal to that angle. And this angle here is equal to that angle. Right. And lastly, what we can say, to find the area of a kite, it is half the product of the diagonals. So the product of the diagonals will be the length of this multiplied by the length of this multiplied by half will give you the area of a kite. It's half the length of the diagonals. And if you're going to talk about the trapezium, it is half the sum of the parallel sides multiplied by the perpendicular height. Right. So again, if you're given a kite, you can make use of any of these properties. Okay, because it's what makes the shape special. It's what makes the shape distinct. Right. So you can use the property. Given the shape, you can use the property. Now, something that I want you to make note of. Can you see how I categorize this information? First, I spoke about sides, then I spoke about the angles, then I spoke about the diagonals. It'll become more useful when we start talking about the parallelogram and the rhombus and the rectangle and the square. But you can see we spoke about the sides, then we shifted to the diagonals here. And then obviously, there's not much we can talk about angles because the diagonals are more significant in this case. But you will see when we go to the parallelogram, I'll first talk about all properties relating to the sides. I will then move on to all the properties relating to the angles, and then I will move on to all properties relating to the diagonals. Why is this important? Because when you are learning, you must learn in this strategic manner. Talk about all the properties about sides, then angles, and then the diagonals. Right, so let's move on, and I'll show you exactly what I'm talking about. There's it here. Right, what is a parallelogram? It's a quadrilateral with both pairs of opposite sides parallel. So this is one pair. This is another pair. We can say that this pair of sides are equal. We can say that this pair of sides are equal and it's parallel, right? We can also say that the opposite angle, so this angle and this angle, and this angle and this angle are equal, and the adjacent angles are supplementary. So you don't have to think about what we mean by adjacent angles. You can just think of this here, co-interior. So this angle here and this angle here are co-interior. Why? Because these sides are parallel and this becomes the transversal. Right, so that's what we mean by adjacent angles are supplementary and the diagonals bisect each other. Don't worry about any of that. You only focus on the properties. So if in the paper you're given a parallelogram, what can you conclude about the opposite sides of a parallelogram? They are parallel to each other. So this is parallel to that and this is parallel to that. Right? Can you see how we're talking about sides? Yes. Let's go to the next property talking about the sides. Opposite sides are equal. So what can we conclude? This is equal to this and this is equal to this. Now, Now, with the parallel property, the first one, we can go to what? Fun angles. Can you see how we're relating it to what now? We're relating it to lines. Again, lines, angles, triangles, polygons are related lines to polygons. How? Using the fun angles. Can you see that? So this is why you need to keep, your mind needs to expand now. This is why I'm slowly starting to open and stretch your mind now. Because we need to, all these topics have to link. Otherwise, maths would not make sense. Right, let's go on to angles. Opposite angles are equal. So this is equal to that, and this is equal to that. Understood? And the diagonals of a parallelogram bisect each other. Right, again, let me just re-emphasize. When you are studying these properties, study the sides, study the angles, and then study the diagonals. So study all of the properties related to the sides, then study all of the properties related to the angles, then study all of the properties related to the diagonals. If your teacher does not stress the importance of this, I am telling you that you need to learn this. It's extremely important. Right, let's move on to rectangles. A rectangle is a parallelogram that has 4 angles equal to 90 degrees. Now, this is extremely important. If you go to the mind map that we discussed at the beginning, can you see what we did here? From the parallelogram, where did the rectangles stem from? It stemmed from the parallelogram. And so if we're saying that a rectangle is a parallelogram, all right? So means it takes all of the properties of the parallelogram. Understood? But the fact that we're giving it a new name, the fact that we're calling it a rectangle, there's a few things that make it different. It's like saying that you and someone else are human. There's common traits between you and someone else, right? You both have 2 arms, you both have 2 legs, you both have 2 eyes, and whatever the case may be. But there's something that makes you different, like your skin tone, your eye color, and your voice tone, whatever the case may be. But that's the point that we're trying to make. So when you shift here, right? If we're saying that a rectangle is a parallelogram, all of these properties here will still remain. That's why I copied and pasted it. I didn't change it. So what, can you see what I said here? A rectangle thus has all the properties of a parallelogram. What is it? Opposite sides parallel, opposite sides equal. Both pairs of opposite angles are equal, and both the diagonals bisect each other. See, side, side, angle, diagonal. But what makes it different? The fact that we gave it a different name, the fact that it's given another name, means that there's something that makes it special. What makes it special? The diagonals are equal in length, and all the interior angles are equal to 90 degrees. And so that's the reason why we say that it's a parallelogram. But what makes it special is the fact that the 4 angles are 90 degrees. So the 4 angles of a parallelogram cannot be equal to 90 degrees. Because if it was, then it does not become a parallelogram. What does it become? A rectangle. Understood? Understood? So that's what makes a rectangle special. That's what makes it different from a parallelogram. What you need to remember is that all of these are properties. All of these are properties. So essentially, if you're given a rectangle in the paper, you can say opposite sides parallel, opposite sides parallel, opposite sides equal. You can say that the diagonals are equal in length. You can conclude that the corner angles are equal to 90 degrees. You can conclude that the diagonals bisect each other, whatever the case may be. You just make use of the properties for now. That's what we are learning. Right, let's move on to the next part, the rhombus. A rhombus is a parallelogram with all 4 sides equal. So if it is a parallelogram, what can we conclude about the first part of the properties? It takes on all of the properties of the parallelogram. So copy it and paste. There's it here. Opposite sides parallel, opposite sides equal, opposite angles equal, diagonals bisect each other. But the fact that we're calling it a rhombus means that there's something that makes it different. There's something that makes it special. And there's it here. These are the properties that makes it special. Is that all sides are equal in length. There's it here. You can say use 1 mark, 1 mark, 1 mark. The diagonals bisect each other at 90 degrees. Right? We don't have that property for parallelograms. And the diagonals bisect both pairs of opposite angles. So you can see at the end here, at the ends of this diagram, can you see what happens? This diagonal at the end here, what it did to the angle? It cut it in half. Here too, it cut it in half. Here too, it cut it in half. Here as well. Right? and you can see that these angles here are equal. You can see these angles are equal, and you can see that these angles here are equal. And if you don't know why, it's very simple. See this here and this here, they are alternate angles between parallel lines. This here and this here, alternate angles between these parallel lines here. Right, so that's why we can start linking sections immediately as soon as you're given parallel lines. As I've said repeatedly, look for the transversals, because then you can use fun angles. Right, and lastly, if we move on to a square, we say that a square is a what? Is a rhombus. And so therefore, we take not only these properties, we take all of these properties, because these are all the properties that makes a rhombus. And we copy and paste it here. So let's go through it strategically, talk about the sides, then talk about the angles, then talk about the diagonals. See, look here. Side, 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 angles, diagonal, diagonal, diagonal. Can you see how I would have studied this for my paper? Talk about everything dealing with the sides, talk about everything dealing with the angles, then talk about everything dealing with the diagonals, and lastly, what makes that shape special? What makes it different from the other shape, the shape that it came from, right? So opposite sides parallel, opposite sides equal, all sides equal in length, its opposite angles are equal, its diagonals bisect each other, diagonals bisect at 90 degrees, diagonals bisect the both pairs of opposite angles, so these ones here. But what makes it different, right? So this here is coming from the rhombus, but what makes it different, these ones here, the special ones, is what? All the interior angles are equal to 90 degrees. So if you look at all of these corner angles, they're all equal to 90 degrees. The diagonals are equal in length. So this diagonal here is the same length as this diagonal here. And the diagonal bisects both pairs of corner angles at 45 degrees. So this is something that you won't get in a rhombus, right? Where these corner angles here are 45 degrees. Right? It won't be the case. So this is what we get from a square only. Okay, so now that we understand all of this here, right? Right, so let me re-emphasize the point of what we've done thus far. These are properties that we can make use only if we know that the figure is specifically a square. Only if we know that the figure is specifically a rhombus. Because if it is a rhombus, we can make use of all of these properties. So given the diagram, you can make the diagram look exactly like this. If you know that the diagram in your paper is a square, you can make use of all of these properties here. So this is what if, then. If this, then these. If this, then these. Right? If this, then these. So on. If the parallelogram, then you can use all of these properties. And I've already explained where this can become significant is you can start using fun angles. Maybe the opposite angles being equal can enable you to solve congruent triangles, right? Those are things that we will deal with as we get deeper into the section. But that was the significance of this, is that we learned, what did we learn now? We learned about properties. I did not talk about theorems yet. We learned about properties. So that's what you need to keep at the back of your mind. The properties and theorems are two different things that we talk about. Properties are what makes up a shape, what makes it different. And so when we learn about a kite, if you're given a kite in the question, you can make use of all of these properties because that's what makes a kite. Understood? Now we can shift our focus to a theorem. Right.